Okay, so principles of data 1 and 2, you'll see in a little bit. Education is the most powerful weapon which you can use to change the world, by Nelson Mandela. So let's go ahead and change the world. So data refers to some fact or information that is accepted as truth. And so any piece of information, whether it's your birthday or it's how long you can hold your breath or how tall you are, these are facts. These are pieces of information that we can accept as truth. And so what data science allows us to do is to aggregate these pieces of information, these truths, in such a way that we can make generalizations or even make predictions regarding information that we have. Okay, and so when it comes to, in terms of me, I live in California. That's a fact. I was born in DC. That's a fact. I'm 35 years old. That's a fact. All these facts are pieces of data. I would say even features about myself. Okay, and so one can say one perspective of this is what is the observation, and that perspective would be a person. Okay, a person. So you can imagine data being discussed in various topics, whether it's literature or biology or even psychology, but they're really heavily discussed and analyzed regards to math, statistics, and computer science. And so we're going to talk about that here. So let's talk about it in math. So in mathematics, you've seen this back in elementary school, integers and numbers. So let's just take it back as a reminder. Integers are whole numbers that are either negative or positive, whereas numbers can be any integer or fraction, decimals, like 122.32, or mixed fraction, so on and so forth, which is hundreds, which could be 122.32. But so yeah, those are the things that we've seen in elementary school. But some other types of data in mathematics are strings. We can say a string as happy. If anything within single or double quotes is going to be considered to be a string. So even when we put a number into a quote, that's considered to be a string. And we also consider, when we say a string, it also could be called a character. Now, the next type of data, some of you all definitely seen before. I know most of you all are engineers, but those that may not be engineer, is something called Boolean logic. And Boolean logic is either true or false. It's just checking if a statement is true or false. So here we have these qualifiers to compare these two numbers. Is 3 less than 10 and 3 is less than 10. This should return true. So when you run this in R, it will return true. But if you say 3 greater than 10, this will return false. Okay, so that's important to note. Okay, so with that being the case, I think you all are ready for some questions. Okay, let's jump into it. So take a moment and answer these next 3 questions. So looking at it, what type of information is 3.4? I would argue this would be a number, right? Because it has a decimal in it, okay? A cat with single quotes around it. I would argue that's a string. And I know those who program in other languages, you're used to calling things characters or chars. In R, we're going to primarily just call them strings. That's how they're referred to, for the most part. Okay. And then the next, I know this is in quotations, but it's more or less that we're taking the 10 less than 10. And that's what we're after. Ignore these quotes, please. And so ideally this should return, if we were to run this 10 less than 10, this should run as false because 10 is not less than 10. Okay. But if we did 10 less than or equal to 10, that would run as true. So if there's 10 less than and then an equal sign right here, because 10 is equal to 10. So that's that. All right, so let's move on to principles of data 2. So education is not the filling of a pail, but the lightning of a fire. Oh, I like that. Fire. Education. Okay, so remember back in data, back before we talked about population, sample observational unit. So the population are all the elements that are possible that we're interested in. A sample is some collection of those elements. If you're looking at Purdue students, let's say I'm interested in all Purdue students. If I were to look at a particular living residential hall, that could be a sample, not the best sample. It's not random, but it's a sample nonetheless. And then I'll say a particular Purdue student would be the observational unit. Okay. So an example here, you're interested in Android games made in 2023. You gain access to only Android games made in April 2023. What's the population? What's the sample? What's the observational units? All Android games made in 2023 is your population. The Android games made in April 2023 is the data that you have access to. And then the observation unit is going to be an Android game made in 2023. That the notes didn't say that, but it should be made in 2023. Okay? So that background information that you already know about, let's go a little bit deeper. Okay, so we have variables and variable types. So technically, you've already heard of this because it's a synonym for feature. So a variable is just any characteristics on the observational unit. Okay, and ideally, which these variables will vary in terms of what we observe. All right, and so looking at the framework of population sample observational unit. Okay, so let's say we're interested in all Taylor Swift songs. Let's say that the API call that we are calling only allows us to get only one album, the 1989 album. I've never listened to it. Whatever, sorry. And then we have the observational unit. It's going to be a Taylor Swift song. Okay, and so what we would have called before features, let's just change the name a little bit and call it variables such as song duration, album name, explicit if it's explicit or not, song genre, pop, country, so on and so forth, and the number of streams on Spotify. So when we have that kind of information, it's imperative that we're able to classify our variable types. What do you mean? Let me tell you. So one particular classification is called quantitative variables, and the other one is called categorical variables. Okay. So quantitative variables, it's important for us to make sense of this, is that it's any variable that can, when we can actually apply some ordinary arithmetic operations on it. So it makes sense for us to do that. So when we can add something or subtract something from a particular number, so on and so forth, or even take an average of it. So the song duration. So we can add, a song could have been longer, so we can add seconds to the actual song duration. So that makes sense. So this is a quantitative variable, just like the number of streams. Let's say there was a glitch in the system, and so there are more number of streams for a particular song than we expected. So we can actually take away. So it makes sense to take away and implement arithmetic operations. So those are quantitative variables. So song duration and number of streams on Spotify. The other type of variables is categorical. But the thing is, there's two levels of categorical. So categorical variables are just names. They're just descriptions, designations, right? Whereas a categorical binary variable only has two options. It's a name and description, yes, but it's only two options. So some categorical variables could be the name of the album. So we're fortunate, one can argue, we only have, just the album name being 1989. But if we had all the albums that she's ever created are we took a random sample of all the songs that she's created, the actual album name would be a categorical variable. More specifically, the song or genre can be considered a categorical variable. Because it could be pop, it could be country, it could be what else has she created? Pretty sure she's not only just pop and country. And then last but not least, if it's only two options, it's categorical binary. So if it's explicit or if it's not. So it can either be one or two. It can't be both. Okay, so make sure you're aware of that. So let's actually do some questions. I think I have 3 questions. I have 4 questions. No, I have 3, just 3. So what type of variable is the age of a song? So how old the song is. What type of variable is the collaboration status of a song? Whether it's soloed or a featuring another artist. Okay. So either it's this or it's that. And what type of variable is the season the song was released? Okay, take a moment and do that. Since we are counting the number of years, let's say years of the song, or how old the song's age, I would say this is quantitative. Here, since it's either going to be a solo or featuring another artist, it's either one of these two. This is going to be categorical binary. And then this, what type of variable is the season of song? Either it's spring, fall, summer, or winter, which makes it categorical. Alright, so when it comes from a math computer science perspective, there are numbers, strings, Boolean. When I say numbers, that includes integers as well. We're just going to clump that together there. But from a statistical point of view, the way we look at the data is like categorical binary, and quantitative. Okay, we're going to primarily be looking at it from a statistical point of view, because then that tells us what type of visualizations we can create. And you'll see what I mean very, very shortly. So we're going to skip this question here. Okay, you can just ignore that. It probably won't even be in your notes.